Hi, everyone. Welcome to our Future of Connected Cooling live stream. We're so excited that you decided to join us tonight, at least tonight here in Copenhagen, but I know that many of you are joining in from places all over the world. We're broadcasting tonight on 4 different channels. We're on our LinkedIn channel, we're on Twitter, we're on our global YouTube channel for Danfoss Cooling, and then we're also broadcasting on our Danfoss Cool US channel in the United States. And I'm really excited to have Thomas and Julian with me here today. We're going to be sharing about the trend of connected cooling that is going throughout the industry and sharing some really, really exciting technologies and solutions that we have in play. And so I want to kick things off very shortly, but I want to remind you that this is an interactive live stream. We want to not just present, but we want to have the conversation with you. So if you're tuning in, no matter where you are in the world, please give us a thumbs up when you like what we're talking about. Hit that like button. Also be sure to leave us a comment or a question off in the chat. We have chat moderators. They're there to interact with you, and they're also passing your questions and comments on to us so that we can address them here, right here in the live stream. So it's really cool to see. I can see that people are tuning in from the US. We've got people tuning in from India, down in Mexico and in Serbia. So it's really great to see all of you joining us here for this live stream, but we want to get things started. So I'm going to hand things over now to Thomas Kolster, who is going to give us a nice kickoff to this topic of connected cooling. Thomas, go ahead.
Thank you very much, Lasse, and hi everybody. I see people tuning in from all over the world. It's truly wonderful to get the opportunity to connect with you about this, at least what I believe is a very exciting topic, the future of connected cooling. So what we have today is we're going to talk a little bit about what does it actually mean when we talk about connected cooling, and we're going to focus around what is available today, what is coming in the future, the way we see it. So we'll try to sort of look into the crystal ball and envision what the future looks like for connected cooling systems. I do have, as you may be able to see here behind me, a whiteboard that I may or may not use. We'll see how it goes. But I also do have just 1 or 2 slides that I want to kick off with. So before we dive into connected cooling and all the nice and cool things that it can do for us, I just want to share with you just 1 slide, because I believe it's easier to show you a slide rather than try to, let's say, recreate that as we go along on the whiteboard here. So let's see. Okay, I'm going to share my screen here. So just bear with me for a while. So what does it mean when we talk about connected and connected cooling? And IoT in particular, Internet of Things, is probably a term that has been tossed around for quite a few years already. So really simply put, just to get a baseline for everybody, what we're talking about is essentially connecting a device to the internet. So it means that in order to do so, we need to have sensors inside the device, whether it's a compressor or it's a full refrigeration system, so sensors that pick up on data. Those sensors will then send the data to the internet. They can either do that directly or through a gateway. We'll not get into the technical details in this live stream, but just to establish the baseline. So the data from the sensors goes to the cloud. The cloud then picks up and collects the data, manages, structures the data, and then on top of that provides a layer to process and visualize the data, because simple raw data typically doesn't bring a lot of value, and what this really is all about is the value that connected assets, connected devices, and connected cooling systems can really bring to us. So the data, as I mentioned, is really here to give us actionable insights, to really let us know about the system or the individual component. That could be a compressor. How is it performing? How much energy is it consuming? And so on and so forth. So that's essentially the whole notion about connecting an asset or connecting a cooling system, providing it the ability to measure how it's operating and send that data to the internet. So with that in mind, let me just go away from the slide here and back to the camera. So as I mentioned, the data that we pick up on can give insights, but it can also trigger automation activities. So data can also initiate other activities that react on data being pushed by certain devices. We'll get into the notion of automation a little bit later. If we look at connectivity in general, some trends and facts and some key numbers, just to get everybody aligned on that, because over the past years, the number of connected devices and systems have grown more or less exponentially. So at the current date, currently we see more than 11 million devices are being connected. So this isn't just cooling devices, that's more in general. 11 million devices go on the internet every day. And today we have roughly about 30 billion devices today. And predictions say that we will get to 75 billion devices by 2025. So the growth is quite staggering. And the devices, they connect in different means. They connect through the internet, through HTTP, HTTPS, 5G, or through mesh networks that you may know from home automation if you've ever ventured into that. So there are different ways of connecting. And when we talk about automation, so there are different things that the value of connected devices bring to us. So it can basically automate simple tasks. So that's the first thing. So task automation. So let's take an example from the refrigeration industry. So understanding or sensing the air temperature in a refrigerated cabinet and putting that up in a report for compliance needs. In Europe, for example, you have HACCP as one of the compliance standards that you use in food service and in food retail industries. And automating the process of automatically picking up on the data based on the sensors and putting that in a decent looking chart rather than manually have to measure temperatures and note down the temperature on a piece of paper or an Excel sheet will save significant amounts of time. So simple task automation is definitely one of the trends that are driven by connected assets. You also can go a little bit further and talk about process automation. So to stay in the refrigeration industry and stay on temperatures, for example, if you have a certain temperature threshold inside a refrigerated cabinet, and the sensor, the temperature sensor, notices that the temperature goes above the threshold, that can trigger a process, or that can trigger an activity. So like a temperature alarm, that temperature alarm can then trigger an additional process where you dispatch a technician, or you send a notification to a system owner or whoever needs to know that the temperature is above its limit. So those are just two examples of the value that connected systems bring. But I want to go back to the last slide that I want to present today. And it's a example not directly refrigeration related, but still the coffee machine here. Because when we talk about the value of connectivity, what's important to understand is that connected systems or connected assets can bring value to different stakeholders. So if we take the coffee machine example, if you're the machine operator or the barista or the guy behind the counter, so to speak, in a coffee shop, it's very nice to know if the temperature levels are right, the pressure inside the machine is right. You want to know if the bean levels are correct, or if you need to refill the beans, or if there's any hygiene needs, so you can ensure that the system works and delivers the best possible product, in this case, the best cup of coffee. So for the store owner, there's additional value as well. You can see sales data. You can see exactly at what time you're selling the different types of coffee or the different products. For the machine manufacturer, you can see sales data, and you can see certain events that may lead to a system failure. So you can use as input to optimize the different components inside the next generation of coffee machines based on actual data. And for the service technicians that need to go on site to maintain and to fix the assets, or in this case, the coffee machine, you can understand before you go on site the current condition that the machine is in. You can maybe through that understand, do I need to bring certain spare parts, certain tools, and what is the service history? So is it the same thing that is constantly breaking down with this coffee machine? So all in all, something that can help you prepare for your visit and therefore improve the time it takes to actually fix the issue. So the value as such is quite significant for many different stakeholders. So depending on you there are different values in a connected system. So if we then hover back to cooling, because I deliberately took an example here that we're a little bit outside just to show the value, so a little bit outside of cooling. But if we can get back to the cooling industry, there are certain trends that we see, and some of these trends that I would like to highlight here before I hand it over. So as I mentioned, connectivity is growing, and we just saw the numbers here. So this means that as connectivity becomes more available, more affordable, there's vast opportunity in connecting more assets and measure more data. And what it means in cooling, for example, is that you can, in a pretty straightforward way, actually connect all your different assets. So it means not just the fixed assets, but also the integral assets or the plugins that will enable you to really get an end-to-end connectivity of all the important assets, whether you are in a food retail store or you are in a food service operations or industrial refrigeration setting like a dairy plant or a slaughterhouse. Really, the trend going towards making connectivity more available really means that you can just add more sensors, harvest more data, and therefore improve the insights that you get out of a connected system. Another thing that I want to highlight is also something that we'll dive into in a little bit later, but the advanced analytics. So data as such, yes, you can use it for visualization purposes and for condition and monitoring, but you can also, by analyzing the data, be able to come towards the state where you can actually predict certain events. So predictive maintenance, going from acting when there is an issue in the system to actually predicting when there will be an issue in the system, so you can fix the problem before it becomes a real issue. Obviously, there's also the energy aspect to it. So reducing energy consumption is certainly something that is super relevant as well. So those are just some of the trends that we're seeing. So I will, with that, hand it over to you, Lasse, to take us forward from here.
Yeah, thanks, Thomas. That was a really great overview of the potential in connected cooling and some of the trends that we in Danfoss are really starting to see. It's cool to be able to peer down the road a little bit, but I know that Julian also wants to dive into what is actually happening here and now. But before I go to you, Julian, I just want to thank all of our viewers. It's great seeing your comments. A lot of you are posting where you're tuning in from throughout the world, and that's really great to see. But we also want to remind you that this is an interactive live stream, that you have the chance to ask questions and get live answers right from our experts here. Thomas and Julian are both really, really excited to interact with you. So as they're talking, drop in the questions. We won't wait until the end to ask them. And so, but of course, you'll also have a chance at the end of the live stream to ask your questions too. So be posting in the chat. And of course, make sure to give us a thumbs up or a like if you are enjoying the conversation and getting something out of it. So, all right, with that, Julian, I'm going to hand it over to you. Can you just share how we're making this reality today?
Absolutely, Lasse. Thank you, Thomas. Yes, as product manager here at Danfoss Cooling, as Lasse said, it's especially my job to make sure that the potential that Thomas was talking about actually comes to reality. So, like Thomas, I've actually just got one slide that I would actually like to share with you. And I think this slide will help basically frame the discussions that we can take for the next 10 minutes or so. So Lasse, just confirm you can see that for me.
Yep, we're good to go.
Fantastic, great. So I also appreciate that some of you may just be in listening mode here. You may be driving or walking home, or so I'll do my best to basically provide a good voiceover for you for what everybody else is looking at right now on the screen. So the slide I'm actually showing just has quite simple, has 3 levels. First level being the applications. So what I want to talk a little bit about is the whole challenge of connectivity. As Thomas mentioned, an awful lot of the potential here is in the value of the data. But let's not ignore the fact that actually collecting this data, understanding what data points add the most value, and then later on, what can we do with them? So it's really a full end-to-end process here that we need to understand. So let me hold your hand and take you a little bit through this journey for the next 10 minutes or so. So on this applications layer, I mean, all of us on this call are clearly interested in the whole industry of cooling. So we all appreciate that there can be very complex cooling systems, those that take a large quantity of different types of assets. And this really is what this slide is doing for us, is it's showing us that depending on what it is, so it may be a compressor pack. So clearly we have a compressor asset or a number of compressor assets within this pack, the heart of the refrigeration system. And then on top of those, we have a full array of pressure sensors. There can be valves, there can be thermostatic valves coming in here as we start pulling in HVAC systems on top of our cooling. Infrastructure gives us heat exchanger assets, and obviously the ability then to generate and benefit from the benefits of heat recovery systems. So what all this basically means is that we have all of these assets with the potential of generating an awful lot of data points. And these data points are managed by what could be actually a cocktail of controllers. There could be different asset manufacturers, therefore with different controllers in this whole infrastructure. So before we even get to generate or realizing the value from these, we then need to make sure, first of all, how do we connect these assets before we can start pushing this into the cloud? So this is where our second layer comes in. So I'm calling this our connectivity layer. So typically the more complex refrigeration systems are the ones that we would usually find in our supermarkets. Most of the assets that I've just mentioned, they would be connected in a network. That network would then be connected and controlled by a central unit. So in this case, on the right-hand side here, example of our system manager range, where we have this asset centrally in the store. It's collecting all of these data points from refrigeration systems, from HVAC systems, from lighting systems, and managing basically all of the controls of that for optimum use. However, it's not always the case that we find that we have these sophisticated networks in place. Many applications whereby some assets aren't networked at all. So these could be things like connected cold rooms or standalone cold rooms that again are cooling a large volume of merchandise. They need to be connected to the cloud, not only for food safety, but also for diagnostics. We're also seeing now a large demand for click and collect refrigerated lockers. So those that you would see locally in your towns, they could be next to petrol stations or somewhere within the retail environment. So again, you order your groceries online, you pick them up on the way home from one of these refrigerated lockers. So again, exactly the same type of requirement. So we need to connect these, and we need to be able to remotely manage these assets.
Hey, Julian, if you don't mind me jumping in here, I think we've got a relevant question at this point, and I want to throw it out there, and I hope I get this name right, but Clodian is asking, how is 5G going to change the way that we connect HVAC devices?
Well, I think, again, very good question. So we're always looking at these advances in telecommunication technology, which is out there. I mean, a number of these devices, so actually timing is perfect, the one I'm on right now. So here we are looking at a range of devices that we have, we call the brand name Prosa. And these are developed really for that type of environment. So if we want connectivity via a cellular network, for example, using SIM card telemetry, that's exactly the type of asset that we would actually utilize in that type of environment. So whether it's 3G, 4G, 5G technology, obviously we're keeping abreast as best we can with the technology and make sure we have the right level of connectivity for that asset.
And if I may just jump in and add to that, Julian, because obviously 5G with the obvious benefits of 5G speed and in particular the very low latency of 5G, I think it's below 20 milliseconds. Obviously opens up for new applications, especially business critical solutions or business critical applications. Edge computing, which means the automation processes that are time critical will be able to be conducted through 5G, which was maybe in older generation networks not so feasible due to latency and speeds and so on. So that's one of the things that the new 5G, as I see it, brings in terms of opportunity and new opportunities in refrigeration.
Thanks, Thomas, and again, thanks for the questions. Also, as you just move along a little bit here, also introduce the concept here of other individual type assets. So again, what we see a lot of in our work within particularly the food retail type environment is where we have retail facilities that have actually quite a lot of integral refrigerated cabinets or plug-in cabinets. Some of you may know them as. So these are cabinets which aren't connected to a network. Typically, they could be promotional cabinets. So a retailer is given these by a food manufacturer, so it's branded. It's used as a promotional cabinet near the checkout counter, for example. Again, depending on what the merchandise is, there is certainly a requirement here to make sure primarily that these the contents of these cabinets are stored at the right temperature for food safety. But again, if these are alarming assets, then these alarms need to be captured. So therefore, they also need to be connected. So again, a portfolio of those we're starting to see an increased demand for. And then on the left-hand side, I talked a little bit about the components on level 1 here on this particular chart. But what we see is, it's not always that you will have same manufacturers of assets with any facility. There can be different assets coming in. There could be different manufacturers. Therefore, we have different control infrastructure across these facilities. But again, from a retailer point of view, their ideal scenario is to actually have one platform that can collect and manage all of this data. So again, that is where these types of universal gateways come in. So we also have those within our Alsense portfolio. Therefore, depending on what the underlying assets are and how, if you like, how old the assets are in terms of legacy, it gives us the opportunity to collect certain amount of data from these assets, and also where we can and where we're legally allowed to is integrate with third-party assets.
Got another really relevant question, I think, then for you here,
Great.
Julian. So this is from John, and he's asking what hosting provider is being used for Alsense? So how are we enabling this technology?
Okay, good question, John. That takes me nicely here into the value layer, as I call it. So this is the whole monitoring and management. So we have all of this data, and you can see right in the center, John, that we have that cloud that we call the Alsense cloud. And Alsense is a digital services platform that we launched back in October, which is a refresh or a complete redevelopment, actually, of our previous services platform. So this now is right at the forefront of the technology. John, to answer your question, it's Microsoft Azure is the underlying architecture that we're using for this platform. And then what we're doing with that is then we are able to develop a whole portfolio of both digital and also managed services. So if I take a few minutes, let me just give you a few examples here. So we've collected all of this data from all these different components and applications, coming through our connectivity devices, push them up into the Alsense cloud. And then just working from left to right, let me just give you a few examples here of typically what we're doing. So you can see there from a remote management point of view. Clearly, we all have smartphones now. We're all very familiar with apps. We're always on. We're always connected. This is exactly the same in our working lives as it is our personal lives. So again, the type of functionality that we're building in now to these devices can certainly support the likes of our contractor or our service provider customers. Those that would prefer to receive alarms, for example, on their apps, on their phones, do a level of diagnostics in there prior to going to store, so they're not basically wasting valuable time heading to store only to find out that a particular issue could have been resolved remotely. So we have activities going on in that area to push a lot of the basic level of functionality where it makes sense into the hands of an app. We also have managed services. So again, within Danfoss, but also supporting our service providers. We have a number of 24/7 monitoring centers, so we can collect all of these alarms and issues that are coming from these stores. We can do different levels of services, so therefore we can triage them. So again, that's in a case we're prioritizing them based on the severity of the issue. Also having some what I call expert interaction services. So if you're perhaps a service provider that needs some additional assistance in understanding, let's say, some of the Danfoss technology that could be in those stores, then again, we can connect you through to the right people within our teams that can provide some high-level insight and advice in terms of how you operate some of these assets. Next along here is predictive analytics. Predictive analytics and predictive maintenance has been a topic which is nothing new. It's been around for a long time. But now with the new technology that we have available, again with the Microsoft partnership that we have, this has given us the opportunity really to press our foot on the gas, the accelerator, and actually move aggressively into this area. So we're working very hard in here, and you'll hear an awful lot more in the coming weeks, actually, about some of the new launches that we're going to do in this area. One of the particular interesting areas would be a complete refrigeration optimization system. So this being something whereby we can score the operation of a particular refrigeration system, but also adding additional value, and that is what are the recommendations that we are making digitally that if they were implemented, they would make sure you had a far more efficient solution, and obviously that will be reflected in your overall score. So a little bit more on that in the coming weeks.
Hey, Julian, I'm going to jump in here with another great question. This one is from Samuel. and he's asking, is this solution only working for Danfoss products?
Again, great question, Samuel. Obviously, our initial minimal viable product that we launched back in October was focused initially on the Danfoss products and the install base that we have. However, as I mentioned on level 2 here, where we have third-party devices, in effect, what this enables us to do is also take data from non-Danfoss devices. We can pull that through, we can then ingest that data, and also make that data available inside the Alsense cloud. So in effect, I could be looking at a cockpit of different dashboards, whether they be alarms or some information about specific asset performance. And we can handle that data the same way as if it was coming from a Danfoss asset or whether it was coming from a third-party asset. Good question. Okay, if we just jump onto the right-hand side. So again, some of the other value-added benefits that we will get from data, and that can be looking at specific assets. So as I mentioned earlier, the heart of the whole refrigeration system, as we all know, is the compressor. So very important that we keep our eye on the performance of the compressor. We collect all the relevant data points that we can. So again, what we're doing, we haven't launched it yet, but we have a compressor insights tool. So again, specifically for that, looking at, for example, suction pressure of our compressor packs, looking at the run times, doing some correlations of different data points. What that will lead us to is, again, on the whole predictive maintenance topic, ideally preventing issues happening by predicting, okay, there may potentially be an issue in 3 months' time with this particular asset based on the data that we're collecting. So therefore, we can advise a service provider that rather than waiting for a routine maintenance, you need to now go and act and do pay attention to the actual compressor before, for example, the ambient temperature rises, and then that will put more pressure on that particular asset. Energy efficiency is something Thomas touched on in his introduction here. We've always been focused at Danfoss on making sure, not only from a hardware point of view, that we give you the best possible energy efficient components, but also in the cloud, an awful lot that we can actually do to make sense of that data. So a number of these things for you. First of all, we have to be able to measure. So that means we need to be able to collect the right energy consumption variables from across the assets and the entire estate. So we have a portfolio of wireless energy sensors, very easily installable, that we can plug in, and then we can transmit that data from the device either through one of our gateways that you see in the middle connectivity layer here, or again, based on the question we had before, this could be going via 3 to 5G cellular networks into the cloud, and then we can manage the data that way. In terms of managing that data, yes, things like energy dashboards are available, but also we're working further in terms of building or enabling you to build very accurate energy models. So what I mean by that is all the influencing variables which play a part in determining what the consumption is. So not only ambient temperature, but we can also look at size of the store and store occupancy levels, for example. And then once we have that baseline measure, we can then use that for forecasting purposes. So then you can start to predict what is your consumption going to be under different scenarios within 3, 4, 5, 6 months' time from now. So again, very good insight to enable you not only to manage your carbon emissions, but also manage the whole energy cost center. Okay, finally, let me give you a slightly different example of also what we're doing with some of this cooling data. And that is, how can we use it for sales and marketing insight? So let me tie in an example that I mentioned before. So let's say we have an individual asset. So we have assets now which are installed, for example, in they could be shopping malls, they could be cinema complexes. And typically, what some of these assets can do for us is if it is a drinks dispensing unit, for example. It's in a cinema complex. We can actually monitor the flow rates of the dispensing of different soft drinks in this unit. So you may think, okay, there's nothing too clever there. But also if you start connecting the dots here and tying it together, if you're a manager of a cinema complex, there is a certain movie playing right now. The demographics of the audience are teenagers, very calorie conscious. Therefore, what they're starting to see then is they're dispensing more of the low-calorie soft drinks during certain periods of time during the week when that demographic is present. So again, they can start using that not only for planning stock levels to make sure that the concentrate in these dispensing machines is at the right level, depending on what the demand is, but also they can use that for also sales data, for predicting that, okay, next Friday when the movie's showing at this time, typically this is the type of consumption and the type of profit margins that they're starting to see around certain brands of that soft drink.
Can I jump in here with a question,
Sure.
Julian? So our good friend over at the Engineering Mindset is here on the live stream, and he just asked a question. So I want to read that one. Could we potentially log what inner components a service technician has worked on or replaced, as well as when this occurred? I'm thinking auto reports for clients to free up time.
Yeah, certainly what we're looking at. I mentioned before about the announcement that we'll make in a couple of weeks around the whole refrigeration optimization system. So clearly, if you like, the first step in that process is obviously making sure that you have, if you like, an inventory list within the application. So we're not just saying, you know, these are some of the recommendations that we're making, because the credibility of recommendations, could be, will certainly be impacted if those recommendations aren't specific to the actual assets that are involved in the store. So yes, based on that, we will be able then to track exactly what is installed, and then also we can build from there in terms of building the maintenance logs of when these things were repaired, who did them, when they did them, when new items were installed. So we're starting now to see the full inventory of everything on my slide here, everything that's in at level 1, right up to what we're doing with it at level 3.
And if I can jump in and add to what Julian is saying, it's definitely the direction that we're heading as well. And one of the more tangible things that we're focusing on the moment is more on refrigerant and refrigerant locks, etc., allowing you to track when a system has been topped off with refrigerant, both for the logging aspect, but also because it can provide additional insights or access as additional data to provide more actionable insights to determine the current state and the potential future state of the system, if we know when refrigerant has been topped up in the system.
Okay, Thomas, I think given the time, I can hand back to you.
Okay, just before you take up the torch, Thomas, I just want to again thank our audience for all the great questions. We see we have some more queued up, but I want to hand it over to Thomas so that he can make sure to mention a few things, and then we'll address a few questions as we get to the end of our live stream today. So Thomas, why don't you go ahead and share what you wanted to share now?
All right. Well, I think we're getting to the point where it makes sense to wrap everything up. So we started out by looking at some of the trends in the industry, and we spoke about what values drivers that are being that we consider as coming out of the trends in connectivity and so forth. So I want to wrap up a little bit, just maybe recapping a little bit and looking a little bit into the future and try to focus on some of the highlights that we see in connected cooling. So allow me to use my whiteboard here for a second. So if we just look at sort of recapping what I said, so we say that data brings insights. And what we're ideally seeing as a trend for the future is not just tell what's going on, but actually tell what's going on or what will be going on and what can you do about it. So if you add another source of input rather than just the data, and you can consider that source domain expertise. That triggers, the way we see it, the ability to do more actionable insights. So data brings insights, but if you add domain expertise to interpret what the data is actually saying, you get much further towards actionable insights and ideally predictive insights as well. If you then on top of that add automation procedures and potentially also artificial intelligence and machine learning components, you get well above or beyond that. Then you get not just actionable insights, but you also get the opportunity to start automation processes. Because that means that we will get towards a scenario, again, if we sort of look into the crystal ball and try to predict what's coming in the future, then we're really essentially looking at a system that potentially could be optimizing itself. So in other words, the orchestra playing itself without the need of a conductor. So the more domain expertise, the more automation and rule engines supported by artificial intelligence and machine learning will allow us to get us towards a state where the system can either optimize itself or at least propose optimization enhancements. So adjusting set points or proposing set points to be adjusted based on the vast amount of data that we interpret. And also based on set point adjustments, you can enable a feedback loop that allows the system to learn, or the machine to actually learn, what is the impact of set point changes in the refrigeration system. So if we adjust a set point over there, how does that impact the compressor performance? How does that impact energy consumption, and so on and so forth? So there are really a lot of different opportunities and values to really go from just data and insights that are by default perhaps a bit reactive to go towards a more proactive and actionable state for the system, where ideally we believe that we will get closer and closer towards a scenario where the system could do its own maintenance, or at least propose its own maintenance, and thereby eliminate to a certain extent the human factor in some areas. We still believe we do need humans to maintain and support refrigeration systems, by the way. I just want to throw that in there. We're not trying to eliminate service technicians and engineers, not at all, but there are certain processes that can be automated or where at least the system can support the decision making for the technicians.
Thomas, I think can I interrupt you real quick?
Sure thing.
Yeah, just I noticed there's a question on YouTube from Steven, and he asked, are we actually going to see Alsense? And I just think that's a really good setup to share, like, where people can find more information about Alsense and maybe see it in action.
Yes, and maybe Julian can also jump in here. We don't have a publicly available demo as of yet, but we might have that in the future. But there's much more to see. So we have I think we can post a link to our website where you can learn more about Alsense, and you can download some more facts and details about the system. We have lots of information on the website, and perhaps maybe that's an idea for a future live stream, that we do an introduction to the system.
I want to quick mention, we have an animated infographic, right, that shows how it all comes together. And then there's also a great video available on our YouTube channel where you can see our monitoring center in Baltimore and see a little bit of how Alsense brings all this great information together.
Just on the back of that, guys, Stephen's question, I know we're doing some regional live streams. I know this one is a global one right now, but we have, depending on your region, Stephen, we will be doing some regional live streams, I think 1 or 2 even next week, but certainly in January, around the globe, and they will be more focused on Alsense. So I would expect in those sessions we will be showing some live Alsense footage. As Thomas said, by all means, get in touch directly with us, and then we can arrange a session for you.
Great. Thomas, I want to make sure I give you a chance to finish your wrap up, and then maybe we'll have a little time for a few more questions.
Absolutely, but let's keep the questions flowing. I think that's a great idea. But I can just at least finish up what I had started here. So taking the transition. So if we try to wrap up in maybe 3 main highlights, the way we see it. There's certainly more, but in the interest of time, let's try to condense it into 3 highlights. So the first being, as I explained, going from reacting to alarms, so more reactive maintenance, you can call it, to proactive maintenance, predicting maintenance need, predicting potential leaks in the system, etc., and potentially even get to the point where the system can perform self-diagnosis, making it easier and faster to do repairs. The other thing that I want to touch on, and there were some questions related to that, is a platform like Alsense. Do we keep it completely self-contained? Absolutely not. I think for a good IoT platform or cloud solution, you need to be able to offer integration opportunities and not build a proprietary setup. So obviously, the second highlight that I just want to bring forward here is the vertical integration. So what we have with Alsense is an example of a tool that can help you optimize your food retail stores, and we also have solutions into food service and food and beverage. But in other cases, it's for larger companies, it would be one IT system out of many. So being able to integrate is something that is very important for any IoT system, the way I see it, and definitely also the same thing goes for our system, Alsense. So integration into work order management systems. I touched on it in the beginning. So when you when the system detects an alarm and the alarm is diagnosed and there is a need to call a technician, then why not trigger that in a work order management system if that's already set up? So again, automating processes that are typically manual, so removing the manual aspect of that. So that's the second one. And then the third one I want to just mention real quick is commissioning. That's another part where I think it's relevant to let's say, or there are obvious improvement areas, setting up the system or retrofitting a controller, making it much easier to just copy settings of one controller over to another. That's another, let's say, highlight or trend that I see that will be a big focus on for the future.
Very cool. All right, we're getting near the end of our live stream here, but I want to just throw out a few more questions for the two of you to answer. And the first one that I have here is from Rasmus, and he asked the question, how do you see connected cooling as an integral part of the smart energy grid, utilizing more fossil-free energy resources and energy flexibility?
I can take a first stab at that one, Thomas.
Yeah, go ahead.
Rasmus, thinking absolutely the right way. I can say that we're also on that journey. We have been providing a number of services in that area for quite some time. I mean, things such as demand response activities that we see a lot of in our supermarkets. So that is something we can offer today. We're also within our platform able to manage, for example, some renewable energy sources. So solar PV, for example, if that is installed in a supermarket environment, and again collecting that data being able to visualize and show exactly the retailer, what are they consuming from the grid, and also potentially what are they selling back to the grid. So that's also an area that we're focused on. And also expanding into more of the smart energy areas. So we interacting in the grid. We're not quite there yet in Alsense, but something which is in our roadmap on the energy side is certainly getting into areas such as peak load shedding, pre-cooling of refrigerated assets to make sure they fit within the grid constraints. So these are all areas we're either doing actively right now, or we will certainly be offering functionality in the Alsense cloud platform to make sure we deliver on those.
And I think it's almost a completely separate live stream because we could easily dive into this, because it's a very exciting topic, especially if we consider the sustainability aspect of the question, right? So getting away from fossil fuels. So Julian mentioned solar PVs as one example. You also have energy storage, so battery storage as one example. So there's so many opportunities, and by tapping into sustainable energy sources and in the same time intelligently managing the load that you have in your system, whether it's in a retail store or it's in an industrial setting like a dairy plant or a brewery. There are so many opportunities in optimize and postpone or delay certain energy consumers that do not necessarily need to happen if you don't have sustainable energy sources to power that. So there's so much we can do, but as I said, it's probably a completely separate live stream that I'll be very interested in taking.
That's so great. We've gone way longer than we originally intended, but that's also okay, because there was so much great information that the two of you had to share, and then all of you out in the chat with your questions and your comments. It's been so awesome interacting with all of you and being able to address what you're curious about live here on this live stream. So we're going to wrap things up for today, but that doesn't mean that the questions have to stop. Continue to drop them into the comments section of whatever platform you're on, and we'll be watching that, and we can even respond after this live stream is over in the coming hours and even in the coming days. So we are very active on all of our social media channels. We try to connect our experts here at Danfoss directly with you. So don't be shy. Ask your questions online, and of course, as Julian mentioned, there are more live streams to come. So, but for now, if you want to stay plugged in, we've got a link that our chat moderators will share where you can get connected to our newsletter and stay always up to date on all the latest news, not only about Alsense, but about a lot of the different solutions and technologies that we offer here at Danfoss. And of course, subscribe to us on YouTube, follow us on LinkedIn and on Twitter and on Instagram. We share a lot of great and exciting different materials and insights. So it's going to be a great time to stay connected with us. But we're just so glad that you joined us for this live stream. And I want to thank both Thomas and Julian. You guys, thanks for coming on here and sharing everything that you have to say about connected cooling and about Alsense.
Thank you, Esther. Thank you, everybody.
Great questions.
Yeah. All right. With that, we'll sign off for the day.